We're going to start today's lesson by taking a look at your homework from yesterday. So yesterday we were working on algebraic expressions, and we were taking a look at some different scenarios, and we're learning about some new key terms like quantities and term and sequence. So we looked at several different sequences and ordered those sequences, figured out how the sequences changed for each term, and then we're able to solve. So your homework assignment was to finish problems 9 and problems 10 on 534 and 535. So if you take a look at problem 9, it said Josh would like to add more trains to his collection. The cost of each car is $8. Write a sequence that represents the cost of buying 1 car, 2 cars, 3 cars, 4 cars, and 5 cars. So the cost of the cars would equal $8, $16, $24, $32, and $40. That would be the sequence I would write for the cost of the cars. Because for every car, it's $8. So you're multiplying by 8 for each car, because each one costs $8. It says, for letter B, describe the mathematical process that is being repeated to determine the total cost for each set of cars. So you added 8 to the sum of each time to determine the cost of each new set of cars. Or another way to say that would be you multiplied the number of cars by 8 to get the product, which would be the cost of each new set of cars. And then for C, it says, what are the variable quantities or quantities that are changing in this situation? Include the units that are used to measure these quantities. The variable quantities in this situation are the number of cars to purchase and the cost in dollars to buy the cars. Letter D said, what quantity remains constant? Remember, constant means that it doesn't change. It says, include the units that are used to measure the quantity. The cost of each train car remains constant as $8 per car. That never changes. And then letter E, which variable quantity depends on the other variable quantity. The total cost of the cars depends on how many cars will be purchased. So we've talked a little bit about that. The total cost of the car, since it depends on how many cars will be purchased, that's what's called the dependent variable, whereas the number of cars is the independent variable. Okay, it stands alone. It doesn't depend on anything else. Now, F said to write an algebraic expression for the total cost in dollars for a train set with n cars. It says rewrite the first 5 terms of the sequence. So an algebraic expression would be 8n, or 8 times the number of cars. And then the cost of the cars would be $8, $16, $24, $32, and $40. The last part of your homework assignment was problem 10. It said to write an algebraic expression to represent each sequence. So it goes 2, 4, 6, 8. An algebraic expression to represent that would be 2n, because if you multiply n by 2, so if we put 1 in for 2, because that's the first number in the list, since that's the first number in the list, our product would equal 2. Since the second number in the list was 4, again, we'd multiply 2 by 2 to equal 4. Okay, and then similarly, 2 multiplied by 3, because of the third number in the list, would be 6. Okay, so n equals the number in the list, in the sequence, and we're multiplying by 2 for each number that is in the sequence. The next expression is virtually the same. It's 2n minus 1, because if we look at it, the order of the numbers is 1, 3, 5, 7. So we could represent this if we said 2 multiplied by 1 minus 1, that would equal 1. 2 multiplied by 2 for the second number in the list would be 4 minus 1 would be 3, right? 2 multiplied by 3 for the third number in the list minus 1 would equal 5. And make sure, again, if you need to make corrections on yours, make sure that you make those corrections now. For letter C, very similar. So again, 2n, so 2 times the number in the list, so it'd be 3 would be the first number in the list, so 2 multiplied by 1 is 2, and then you have to add 1 to get to each number, so that sum would be 3. For the next number, that's the second number in the list, plus 1, that would be 5. 2 multiplied by 3, second number or third number in the list, plus 1 would equal 7, and so on. Now the next one, letter D, probably challenged you a little bit to see how things were increasing. Okay, but if you look carefully, these are our powers of 2. So 2 to the first power equals 2. 2 to the second power equals 4. 2 to the third power equals 8. And 2 to the fourth power equals 16. Because 2 multiplied by 2 equals 4. 4 multiplied by 2 equals 8. And 8 multiplied by 2 equals 16. So those are our powers of 2, and we can write that as 2 to the power of n. The last example, letter E, starts at 101 and then goes 102, 103, 104. So if we look at the terms, the first term in the sequence is 101. So if it's the first term plus 100, that would equal 101. Look at 102. It's the second term in the list. Plus 100 equals 102. The third term plus 100 equals 103. And I'm a little off the page there. Okay? And the fourth term is 104 plus 100 would equal 104. Then as we continue this lesson, it says, as you learned previously, an algebraic expression contains at least one variable and sometimes numbers and operations. A term of an algebraic expression is a number, variable, or product of numbers and variables. So let's make sure that we mark that part of our text. A term of an algebraic expression is a number, variable, or product of numbers and variables. So it says consider the expression 3x plus 4y minus 7. Now that might look kind of strange because we have multiple variables in that expression. The expression has three terms, 3x, 4y, and 7. The first operation is addition, the second operation is subtraction. The first term is multiplied by the variable x, so 3 multiplied by x. We already talked about how whenever there is a variable right after a number, that means multiplication. Number 3 is the numerical coefficient of x. Plus 4y, the second term is 4 multiplied by the variable y. The third term is a constant term of 7. Okay, it doesn't change. But the second operation is subtraction. First operation is addition. So then if we take a look at the next page, and I just switch back to your page so you can focus on this, let's consider two algebraic expressions, 8 plus 5x and 8 minus 5x. So it says, for letter A, identify the number of terms in each algebraic expression. So in the first term, or in the first expression, the first term is 8, and the second term is 5x. So in the first expression there's 2, and then in the second expression, the first term again is 8, and the second term is 5x. So in both there would be two terms. In B it says identify the operation in each algebraic expression. Obviously in the first expression it is addition. So we have our plus symbol there. I apologize, my marking tool is a little bit off. And then in the second one we have this subtraction symbol. So the operations would be addition for the first expression, subtraction for the second. And then the terms in each algebraic expression. So for 1, it would be 8 and 5x. And then for 2, it would also be 8 and 5x. And then for D, it says what is the same in both expressions. And it says, since we said that the terms were in both were 8 and 5x, the terms are both the same in each expression, and the number of terms is the same as well. And what would be different would be the operations themselves. All right, so I'm going to put up the answer key here. Make sure you get these things filled in your book as well. So again, make sure you get the answer key filled in for number 1 in your book as well. And then I'm going to give you a moment to work on number 2. And once you are done with number 2, then you can continue the video. So if you're not done with number 2, which you shouldn't be yet, hit pause, finish number 2, and then hit play to continue watching the video. Alright, hopefully you got number 2 done. Now if we take a look at number 3, it says write an algebraic expression that represents each situation. So we took a look at A, it says Diego drove at a constant rate of 60 miles per hour. How many miles did he drive in T hours? So if I read that again, Diego drove at a constant rate of 60 miles per hour. I know if that says constant, that means it doesn't change. So it's 60 miles per hour. Okay, 60 miles per hour. How many miles did he drive in T hours? So in T hours, alright, in T hours, it's 60 miles per hour, so it's going to be 60 T. And again, I apologize for the neatness of my writing there, but it would be 60 T for that algebraic expression. If we take a look at B, the cost of a school lunch is $1.60. How much money was collected if N students bought lunch? So again, how much money was collected if N students bought lunch? The cost of a school lunch is $1.60. So you have $1.60. Alright, and you have N students. For one student it would be $1.60. For two students it would be $3.20, because $1.60 multiplied by 2 would be $3.20. Okay, so the expression would be $1.60 multiplied by N. Take a moment and do problems C, D, and E on your own, and then when you're ready for problem F, you can unpause the video and watch me go through problem F. So right now, pause the video and then solve C, D, and E. Alright, let's take a look at problem F then. Chairs cost $35 and sofas cost $75. How much would it cost to purchase X chairs and Y sofas? So in this case, there are two variables. Now the chairs cost $35 and sofas cost $75. How much would it cost to purchase X chairs? So X chairs, it would be 35 multiplied by X, because 35 multiplied by the number of chairs and you'd have to add that to the number of sofas. Sofas cost $75 multiplied by the number of sofas, so it'd be 75y. Okay, so 35x plus 75y. Alright, take a moment to fill that in your book, and then do problem G. When you finish problem G, then you can unpause the video and watch problem 4. So problem 4 says write an algebraic expression that represents each word expression. It says the quotient of a number n divided by 7. Now remember, I can write this as a fraction, n over 7, because a fraction bar means divide. So my algebraic expression would be n over 7. What I'd like you to do next is to finish B through H. So take a moment, finish B through H. The last problem that we're going to do today is problem 5. It says construct an algebraic expression for each description. It says there are 2 terms. The first term is a constant added to the second term, which is a product of a number and a variable. Wow, that is a mouthful. So let's slow down, reread it, and try and make sense of it. So it says construct an algebraic expression for each description. So it says construct. Now I know that construct means to build. So I have to make an algebraic expression. So it says there are 2 terms. Okay. The first term is a constant added to the second term. So the first term is a constant. Okay, that means it doesn't change. So I'm thinking that's a number. So if I say that's 11, let me erase that. That didn't look very good. So 11. Okay, so there's my 11. That's my first term. It's a constant, and it's added to the second term. So that's going to be plus, all right, which is a product of a number and a variable. I know a product is the result of a multiplication, and the product is a number, the result of a number and a variable. So I have to multiply a number with a variable. So I could say that that's 3, and I could say that that's n. So if I look back at this, it says there's 2 terms. I got my 2 terms, 11 and 3n. And it says the first term is a constant, 11. It's constant, it doesn't change. Added to the second term, which is 3n. It says which is a product, so a multiplication, of a number, I have 3 there, and a variable, which is n. So 3n. So I've met all the requirements for that algebraic expression description, and 11 plus 3n is an appropriate algebraic expression for that description. And what I'd like you to do now is finish B, C, and D. And when you finish that, you are done for the day. D-O-N-E, done. Alright, so hopefully you finish that up before you had to leave for the day and have no homework for tomorrow. Make sure you have those pages completed for tomorrow. Again, those were relationship between quantities pages 536 through 538. Thanks for watching, and we will see you in class tomorrow.